What we're going to be talking about here is solving compound inequalities. We have two to solve. We'll be going through them both. The first one, 5 is less than the quantity of 2 times quantity x plus 3 minus 5 is less than or equal to 7. Regardless of how we approach this, the first thing to do is to combine like terms, distribute, and do all that. So 5 is less than 2x plus 6 minus 5, which is less than or equal to 7. Then we combine like terms. 5 is less than 2x plus 1, which is less than or equal to 7. Now, as we noted in the previous video, when you have something, a compound inequality like this, it's actually two inequalities being expressed at the same time. We have 2x plus 1 is less than or equal to 7, and we have 2x plus 1 is greater than 5, just changing the direction of that inequality. And we can solve these two inequalities separately, or we could actually combine them and solve it in the combined version. Because after all, if we have 2x plus 1 is less than or equal to 7, the first step of that is going to be to subtract 1 from both of those sides to get 2x is less than or equal to 6. But if I have the other inequality over here, well, I can subtract 1 from that as well. And so I get 4 is less than 2x, which is less than or equal to 6. Then I divide everything by 2, and I get 2 is less than x, which is less than or equal to 3. I could have kept them separate, but I can keep them together and solve it maybe a little bit more efficiently. Graphing this, of course, the step there is going to be to create the number line. 0, 1, 2, 3, 4, and any other points that you can fit into there. And it's going to be an open circle on the 2 because we're not including the 2, and a closed circle on the 3 because we are including that, and then shading between them to get that tiny little dumbbell there. So that's going to be our solution and our graph for this particular inequality. For an OR inequality, because after all this is an AND inequality because we're stating that this expression is both greater than 5 and less than or equal to 7 at the same time. For an OR probability or an OR compound inequality, the process is pretty straightforward. We have two separate inequalities and we solve them separately. So subtract 4, we get negative 3x is greater than 12. Only thing we got to be careful about here is when we're dividing by a negative 3, that inequality is going to change direction because anytime you divide by a negative, that's what happens. So I get x is less than negative 4. Going over here, I get, again, minus 4, negative 3x is greater than negative 9, divide by negative 3, divide by negative 3, I get x is greater than positive 3. So I have two inequalities now, x is less than negative 4, or x is greater than 3. Set up my number line. I'm going to cheat a little bit in this one and just sketch in a few of the points. So negative 5, negative 4, I'll label that. Negative 3, negative 2, negative 1, 0, 1, 2, 3, I'll label that, and then 4. I don't really have enough room to fill in all of those, but you get the idea. And then finally, I have an open circle on the negative 4 because I'm not including it. Shading to the left because I want values for x that are less than the negative 4. Then similarly for the 3, open circle, shading to the right because I want values that are greater than positive 3. And then that's my graph. That would be my solution. Now I have that x is less than negative 4 or greater than 3 for this one, and x is between 2 and 3 for the inequality on the left.